Stop.
All right, gang, today's lesson is going to look at an introduction to our geometry unit where we're going to classify two-dimensional shapes. So I know you've got some background with geometry, but as we get into fifth grade, really we're going to kind of focus in on defining attributes of shapes and really taking a deeper look at 3- and 4-dimensional shapes. So we're going to start off with the ability to classify shapes based on their properties, which really leads us into what is a polygon. So this will be kind of the foundational place for our unit, and that is that we're going to look at being able to look at a shape and say, are you or are you not a polygon? You know, for me, one of the things I think about, and I know a lot of movies are being remade these days, but I was always a fan of the original Charlie and the Chocolate Factory, or Willy Wonka and the Chocolate Factory. I get the names messed up now, but the Gene Wilder version, not the Johnny Depp. But in both movies, they've got the scene, and this particularly sticks out in the newer movie where they're going through the factory, and the squirrels would get the nut, would come down, they would shake the nut, and they would decide, is it a good nut or is it a bad nut? And to some degree, you're going to be doing this throughout the unit with shapes, is you're going to be able to look at it, and based on what are some of the attributes, or what is the shape, what does it look like, what are the angles, sides, and so forth, that you're going to decide, is it a this or is it a that? And every time I think of this unit, that picture comes to my mind of those acorns or nuts kind of dropping down. The squirrel grabs it and has to look at it and to kind of make a determination based on kind of visually, hey, are you good or are you bad? So with the polygon, if we were to have a shape kind of fall in our lap, so to speak, is we've got to have a couple things that are necessities. Number one, it has to be a closed shape, meaning all sides come to an eventual, it closes up. Um, in order to do that, it has to have 3 or more sides, because no side can have curves in it. And then last and certainly not least is all the sides have to come to an endpoint. They cannot overlap as such. So when we look at the polygon, it's going to be a closed shape, 3 or more sides. And in fact, we're going to learn that if it has 3 or more sides, it's going to have 3 or more angles. All sides are going to be straight, no curves. And then all sides must meet at an endpoint. So we'll run through a quick little activity to where we'll have you an opportunity. Is this or is this not a polygon? Well, I'll take kind of the driving seat, let's say on the first one. I'm looking at this. Number one, this is a closed shape. As you'll notice, all sides meet. Also notice that all angles or all sides come to an end. If you see here, all of them come to an end point. Now I look at this, there are no curves. This is clearly a polygon. What about this one? And I'll stop for a few seconds, let you mentally answer it. And you should say no, it's not. And there are a couple of reasons. I mean, some we could maybe argue about. Um, Number one, is it a closed shape? Yes, it's closed, but the problem is it has a curved side. Now, we could argue that how many sides are there? One, I would probably say there's just one side that does what? It just goes in a circle, right? So it's not a polygon. Is it a shape? Yes, certainly. It's a circle. It's one of the more popular shapes. It's simply not a polygon. What about this one? Well, once again, it is a closed shape. It closes up right here. But what about the curve? And that becomes the issue. And again, one of the things, if we were in class going through this, I would make the argument, hey, I would ask the question, how many sides? And half of you would say there's one side, the other half would say two. For me, it's one side that is kind of broken up right here and bent around into this shape. But regardless of how we would have came out there, we know this is not a polygon. We take a look at this, and you would say it is a polygon. It's a polygon because it is a closed shape. It has 3 or more sides. All sides are without curve, or they're all straight. And all sides come to an end point. Notice that there's not a side that extends past like that. We don't have that here. So this is definitely a polygon. That would definitely be a polygon here. Is this a polygon? Well, initial glance, I'm sure you see this opening, which would disqualify it. But in that, we could also look and say, well, it's got some things that do make it a polygon. All sides are straight. It has 3 or more sides. But all it takes is one element to disqualify, which is that it is not a closed shape. So we want to kind of watch ourselves there. Again, popular, it's a shape, it's a heart, but it's not a polygon. It's a closed shape. I would argue this one has 2 sides, but both sides are curved. Even the sides themselves, they do come together at an endpoint to meet. Um, this is one in class we would have a good little argument about. So I'll let you think about this. Is this a polygon or not? Now, my assumption is half of you are going to say yes, and the other half will say no. Um, I would argue that the lines here overlap. So while this is not a polygon, I would say it is polygons plural, because if you were to cut it in half right there, you would have 2 triangles. But the sides would have to meet these sides right here, and let me kind of clean this up right here. For this to be a polygon, this side, it must stop here, and I'll kind of drill in here, is we would want to cut off right here, and then that come here forming an angle, and then have nothing on top. So, and that's a little bit of a, I don't want to call it a trick question, but just a, hey, the sides keep going, which make it not a polygon. It could be, you can make an argument, 2 polygons stacked on top of each other, but it's definitely not a polygon if we were to look at that as one shape. What about this pentagon? Is it a polygon? Well, certainly. It's closed. It has all straight sides. And what's the last one? Closed, straight sides, no curved shapes. So it's definitely easy one to spot right there. So that's really the gist of a polygon. So then once we kind of get the feel of what a polygon is, then you kind of take it and say, well, there are regular and irregular polygons. So a regular polygon is when all angles and sides are equal. If it's not that, it's irregular. In fact, I will say this, most of the polygons that you either attempt to draw or you come across are irregular. The most popular polygon in the world is probably the square or maybe the triangle, the perfect triangle, the triangle you envision in your head. So that's when, again, as we're going to do a similar activity, we're going to kind of look at, hey, let's take a look at some of the, some examples, but we're looking for all angles and all sides to be equal. Otherwise, it's not. So we look at this. Now, here's where there are times where simply the way the technology might stretch something as it goes to a higher ratio view, it might stretch it. So I might look for a way to communicate with you sides are equal. And if you see marks like this on a paper, on a shape, these are called congruent marks. And what a congruent mark is saying is everything with a 1, they're all equal. So this shape here is a square. All of them are equal. You know this from last year. If you see the little square over here, it's saying those are right angles. And we know that a shape with all equal sides and all right angles, there were 4 equal sides, 4 right angles, is going to be a square. So we know this is a square, and a square would be a regular polygon. We look here. Now, visually, I can see these 2 appear to be the same length. That's why I put the congruent marks there. But if you'll notice the horizontal sides, I don't know how long they are, but what I know is they appear to be the same. So I'll put 2 marks there. So what I'm communicating to you right now is the left and right sides, the vertical sides are the same. I don't know how tall they are. All I know is that they're the same, therefore I use congruent marks. And then I know that my horizontal, my top and bottom, are also the same. I don't know how far, so I use congruent marks, and I use 2 to say the 2's are the same and the 1's are the same. Now, when I look at this shape, a couple other things I could say about it is I could mention opposite angles appear to be equal. And so if I were to say angle A, B, C, and D, I would be able to say B and D are obtuse, and then A and C are acute, meaning B and D appear to be greater than 90 degrees, and A and C appear to be less than 90 degrees. Again, these are things that we'll explore later in the unit. Right now, we're simply looking at, are all sides and angles equal? The sides are not equal. And in fact, we pointed out that the angles are also not all equal. 2 are equal and 2 others are equal, but not all of them. Well, in this one, it's pretty obvious that we've got actually several different shapes or sides working. Um, these two look to be completely different. This here is going to be a third length, and this would be a fourth one. So this is kind of a mess of a shape in terms of looking at it irregular or irregular. It's definitely irregular. None of the um, sides are the same. We actually could say 2 angles appear to be the same. We do have 2 90-degree angles, but if I were to compare again, if I'm going to label A, B, C, and D, B and C are not 90-degree, and they're definitely not equal to each other as well. So as we kind of begin to look at this, we can see that definitely going to be an irregular. This is one that always causes a little bit of confusion. It's a star. I'm going to go ahead and tell you all of these are the same. So all sides are equal. So then I could say, well, A, B, C, D, and E angles, guess what they are? They're all equal. Well, the problem becomes this angle right here. There is an angle there, it's an obtuse angle. And so I would definitely want to say, if we kept labeling angles, if we said A, B, C, D, E, F, G, H, I, and J, well, the problem is A, B, C, D, E are not the same as F, G, H, I, J. A, B, C, D, E are acute angles, and um, F, G, H, I, J are obtuse angles. So while all sides are equal in this particular shape, all angles are not equal. Therefore, this is an irregular polygon. So sometimes the sides might all be equal, but unfortunately, the angles are not all equal. Um, Kind of looks like home plate, which is getting us ready for baseball season if it'll ever happen. I can look, and those 2 vertical appear to be the same, but when I look at this top and these 2, the sides aren't the same. It appears we have 3 different side lengths. Again, if I'm looking at the angles, looks like I have 2 90 degrees there. But then if I were to say angle A, B, and C, A and C might be the same, but B is different than those 2. And then if we were to come up here and say these are D and E, they're both 90. And so we don't have all angles are the same. So there's a lot of different ways I can peel that apart. And I want you to notice as I'm labeling these angles, it's giving me talking points to where if I say, hey, angle A, that your eye should be kind of fixating down to here. If I were to say the line AD, you should be thinking about right here. And it gives us a way for me to talk about it and to draw your eye to certain places. Regular or irregular. Um, what if I told you this? Well, that's going to point to a regular, because if all sides are equal, guess what? All angles are going to be equal in this particular triangle. So we'll learn more about triangles in our next lesson, but this is the perfect triangle. What about here? Did you notice what happened when we went from this triangle to this one? Do you see how this side got smaller? So we know these 2 are the same, but this one down here is the base, or our horizontal side on the bottom, it's not the same as the two upright ones. So this is the triangle we will talk about and learn a little more. But one thing we can't say about it is definitely not a regular triangle. Um, be careful here. What if I told you all sides are equal and every one of these are 90-degree angles? This would definitely be regular. A lot of times, folks, we want to call this a rhombus. And we'll talk in a few days about why it's not a rhombus, it's still a square. And although I could call it a rhombus because a rhombus says all sides are equal in two sets of parallel sides, the most appropriate or geometric name would be a square. So, but the square, I've just tilted the orientation of the square, so we're okay with that. Okay. So quickly, let me just recap where I want you to be before you move into the practice session. I want you to know the four attributes of the polygon, which are straight sides, its closed shape, minimum of three sides, and that all sides meet at an endpoint. That's hugely important as we go on. Then think about the regular and irregular polygons. A regular, all sides and angles are equal, whereas an irregular, they're just not. All it takes is one side or one angle not being equal to the other sides or angles, and then it is an irregular polygon. What I would like for you to do is think about classifying shapes by sides, okay? And this will be kind of an independent study that you're going to do in just a second, so hang tight on that. And then just keep in mind our primary focus as we move forward will be triangles and quadrilaterals. We're really going to go deeper into being able to classify. So for right now, this will be a lot of memorization. There's going to be a lot of terminology that I've thrown at you. You know, even today alone, I'm kind of glancing at the page here and I see polygon, I see regular, irregular. I see even the word classify. I see triangle, quadrilateral. I used the word congruent earlier, which means equal. And so there are a lot of terms that I really need you to kind of soak up. So maybe this is a good time to start a little journal, jotting some of these words down so that as they come up, you're able to quickly reference them and go, okay, here they are. So let's move into the practice activity to show or to give you a little opportunity to practice what you know, okay? So good luck on the practice. It'll be next, and then we'll take a quick little exercise. Thanks, guys.